Alright, so this is the NIHS-DIO versus GeoTest board, and I've heard of a lot of DSMs saying that they've run across GeoTest in their opportunities and are losing to GeoTest. And I want to say that we should never lose to GeoTest because of this. This is what their 100 megahertz eye diagram looks like, and this is what a National Instruments 100 megahertz eye diagram looks like. Now, this is not a marketing gimmick. This is not something I drew. This is what HSDIO R&D uses. They use a Tektronix. We used a Tektronix scope to get this 100 megahertz eye diagram. We used their cables. We used their connectors. So if we're losing to this, that's not a good thing. Now, GeoTest does have a few modules that we don't. If you look at their 6U product line, they've got something called the PXI GX 5055, which is 50 megahertz plus minus 15 volts with per pin PMUs and per pin voltage. Right now, we do not have anything on in a 3U module for that, but we do have something on our roadmap. But let me know if you hear about customers asking for high voltage, high clock rates. We recently released the 6548. We have capabilities of going up to 400 megabits per second. This is something GeoTest cannot do. We also have multiple banks of data delay that GeoTest does not have, and our synchronization capabilities with NIT clock is a lot better than GeoTest. Of course, if usually we lose to opportunities because of low cost. Now with FlexReal, with similar specifications and memory options, we come in at about $2,000 cheaper than GeoTest. And we have a lot of wiggle room for discounting, so if we get into a price war with GeoTest, we should probably consider FlexReal and see what we can do with that. Now I do have a couple of demos here. I have the GeoTest 5292 here. I'm using their cable and their terminal block and feeding it into a PXI 5154 high-speed digitizer. I also have the PXI Express 6548, which is a high-speed digital I/O module that we provide, capable of 200 megahertz clock rates. Now let's go ahead and switch over to my VI here, and you'll see what the signal looks like. The signal that you see on the top is a 100 megahertz signal from the HSDIO board. The signal that you see at the bottom is a 100 megahertz signal from the GeoTest board. And really, this is not, we cannot really call this a 100 megahertz signal. It's embarrassing to call this a digital signal. On the software side of things as well, we had a customer who gave us a pattern and asked us to import it and use it on our digital boards. We were pretty successful using the digital waveform editor, and you can see that we have output and input lines. Now for a demo, I'm going to use the DIOeasy software and use their Wiggle importing capabilities, which is exactly the same file that we imported. So I'm going to click on File, Import Wiggle. I'm going to select the exact same Wiggle file and click on Import, and you see that this file gives you an error saying cannot open file, blah blah blah, internal file error. And this happens with every Wiggle file that we try to use with this GeoTest board. So remember that when it comes to GeoTest, they have a pretty bad eye diagram. Their signal quality is nowhere as good as National Instruments. All of this information is available on niweb/marketing/HSDIO, and you can go ahead and show this to customers. Do not leave it with them, but you can show this eye diagram to your customers, letting them know that they should not be using the GeoTest board because they will not be successful with it. Thank you.